Cool. We are online now. So, hello everyone. Welcome to yet another PyTorch Lightning 1.6 release live stream. Today, we are going to discuss about Habana integration. So, in 1.6, we collaborated with the folks from Intel and integrated this new accelerator called Habana that uses Gaudi accelerators to enable deep neural nets and also helps you save cost while training them. So we'll discuss more on why, how does it work, and like what's the architecture that helps you with the cost saving, and then we'll talk about how you can use that with PyTorch Lightning. So today we have with us Milan and Jian Yang from Intel, who will talk about what are Habana accelerators, and then we'll have Kaushik that will show you how it works with PyTorch Lightning. So let's get started with Milan.
All right. Well, Yanying, if you wouldn't mind putting up the slides. Good morning, good afternoon, good evening to everyone, whatever the case may be. My name is Milind Pandit. I'm a solution architect at Habana, which is a wholly owned subsidiary of Intel Corporation. So I work with the sales team to talk about our value proposition to customers. And Jianying is one of our application engineers on our team. Part of her job is making the Gaudi Accelerator easy and smooth to adopt by our customers. So let's maybe start with the first slide, Jianying.
Yes, just a second. Let me share. Yeah, can you see my screen?
Yeah, can you? Perfect. Yeah. So our presentation is titled "Train More and Spend Less with the Habana Gaudi AI Training Processor." Next slide. So at Habana, we have understood for many years the explosive demand for deep learning training. As everyone knows, there are a growing number of applications for machine learning and artificial intelligence. Models are getting more and more complex. I think everyone should be familiar with GPT-2 and GPT-3 and Megatron. These represent machine learning models with hundreds of billions of parameters that require training, so the complexity is growing. And customers who are trying to derive value out of machine learning and AI, they are having to train and retrain these models pretty frequently. There was a report recently from IDC, which indicated that 74% of their respondents were running 5 to 10 iterations of training in a month, and more than half of respondents were retraining models weekly or even more often, 26% rebuilding daily or hourly. So the importance of training and retraining models is clear in order to derive value from machine learning and AI. Next slide. Another insight that came out of the IDC report is that over half of the respondents are saying that there is a barrier to implementing AI and machine learning solutions, and that primary barrier is the cost to train. I think many of us as data scientists, we're concerned with performance, and that is important because as we train and retrain models, the performance of that training, the speed of that training is of course important. We don't want to wait very long when we train and retrain models. But ultimately, to implement an overall solution, the cost is the primary barrier. Next slide. And this is a barrier in a wide variety of industries, right? Manufacturing, retail, medical, transportation, even in social media. And what Habana has understood is that in all of these industries, there are a few major areas where AI and ML are being used. The first area is computer vision, and that can be divided into object detection and segmentation, or more basically image classification. These are two areas of computer vision that are extremely important in the world today. The other area is in natural language processing. And with BERT and GPT-2 and GPT-3 and other such models, there's a huge amount of innovation happening in the area of natural language processing as well. But again, the primary barrier that companies are facing in embracing these uses of AI is cost. Next slide. So because cost is the primary barrier, we have built the Gaudi 1 training accelerator to directly address the cost problem. So what you see here is the cost to train a ResNet 50 model on the left side, or on the right side, the two charts represent the cost to train a BERT large model. And when you compare the cost to train on Gaudi against the cost to train on competitive products, namely NVIDIA V100 and A100, then Gaudi illustrates a significant cost savings, right? So anywhere from 31% against V100 on BERT large to up to 75% in some cases. And again, this is a cost to train these models from scratch. In the case of BERT large, the performance, the report is generally given in phases, phase 1 and phase 2. And the cost is dependent on, the cost is based on the cost to train in AWS using the DL1 instance, which is a Gaudi-based instance. So let's double click a little bit on how we're able to achieve this cost to train improvement. Next slide. So I always like to measure, the performance per dollar of Gaudi in comparison to competitive products. So this is the numerator of that equation, which is the performance. And what you see here is that when training a ResNet 50 model, this happens to be on the ImageNet dataset, standard dataset. When training a ResNet 50 model, Gaudi can train in a period of time which is somewhere between V100 and A100, faster than V100, but maybe not quite as fast as A100. And that is true whether you're comparing a single Gaudi against a single A100 and V100, or 8 Gaudis compared against 8 V100s and 8 A100s. So the performance part of that equation, performance per dollar, is somewhere between V100 and A100. Next slide. And this is the performance on BERT large pre-training, phase 1 and phase 2. Again, you see performance somewhere between V100 and A100. For phase 2, the nature of the workload is that it is extremely well tuned for the Gaudi 1 architecture. And so we actually get much closer to A100 performance levels here. Next slide. So where is this performance all coming from? I'll go through some of the hardware aspects of the Gaudi processor. So the Gaudi processor has subcomponents, which are mainly a number of, it has subcomponents including matrix multiplication engine for general matrix multiplication, and multiple tensor processing cores, which are running the nonlinear and element-wise ops. And those cores are fully programmable. If you look at the number of these cores and compare it with the number of cores on, say, a typical GPU, you'll actually find that there's a smaller number of these. Now, there's a couple of advantages to this. Number one, the utilization of the silicon is higher on Gaudi when compared to the average GPU, because there's a smaller number of all of the work. The other kind of consequence of this is that we can train on smaller batch sizes. Those of you who have trained on GPUs may be familiar with the need to kind of fit that GPU and its cores by using very large batch sizes. And that's not always convenient or desirable. So because of the use of a smaller number of cores in our single Gaudi architecture, we're able to train on smaller batch sizes. Now, you may be wondering what we've done with all of the silicon, because if we take a certain silicon die and compared to a GPU use a smaller portion of it, then what are we doing with the rest of it? That's a reasonable question, and the answer is we very, very heavily in high bandwidth networking between the chips. So Gaudi is the only AI processor to integrate 10 Ethernet ports. These are 100 gigabit, what is called RoCE ports. And RoCE stands for RDMA, or Remote Direct Memory Access on Converged Ethernet. The idea is when you connect Gaudi accelerators together in a network, number one, that's very easy to do because the networking is built in. Not a lot of spare parts required to be purchased. Number two, once that is done, each of those Gaudis is able to communicate with the others extremely rapidly and communicate with a large number of them. And RDMA basically means it's able to memory that happens to be residing physically on another Gaudi. So the benefit of this is that when you do scale your model to perhaps a larger data set, perhaps a larger, more complex model, you can use additional Gaudis and get linear scalability or near linear scalability. We lose very little performance in terms of the communication bandwidth. So 2 Gaudis will train almost 2 times as fast as a single Gaudi. 4 Gaudis will train almost 4 times as fast as a single Gaudi, and so on. You will not find this to be the case with GPUs, because GPUs are using all of that silicon for cores, less of it for networking. And so we believe that as models grow larger and more complex, as data sets grow, then our architecture will be superior to the average GPU architecture. Next slide. All right, we talked about this. Sorry, go back. Okay, so let's talk about how to gain access to Gaudi processors. As I mentioned before, Gaudi servers are available today within the AWS offering. So any one of you can go to AWS using your account and spin up start up EC2 and spin up a DL1 instance. This will be a server with 8 Gaudi devices on it. For those of you who are maybe operating in environments where you have your own data centers and your own servers, we work with Supermicro to sell on-premise servers, each of which has 8 Gaudis. And then for those of you who might want to try before you buy, Supermicro also offers a kind of cloud experience where you can evaluate Gaudi servers before you actually buy one and install it on premise. For those of you who have used infrastructures like Kubeflow for large-scale machine learning pipelines, Habana recently acquired a company called Converge.io, and they provide a software layer on top of these servers based on Kubernetes, and it provides kind of a very user-friendly way to run and keep track of large-scale deep learning training experiments. Next slide. All right, so let's talk a little bit more about the software, and I'll say a few words on this slide and then hand it over to Jianying to talk in more detail about the technical architecture of the software. So the primary software interface to the Gaudi device is the popular frameworks, PyTorch, TensorFlow, and now, of course, PyTorch Lightning. Our goal from the beginning has been that any model that can train on PyTorch or TensorFlow, it can train on Gaudi. And that is our commitment. And we do that in a very simple way. Basically, we prepare operators that are optimized for Gaudi. We integrate those operators into the frameworks so that for the end user, it's nearly transparent. Now, certainly, if you're writing a PyTorch training script and you've explicitly targeted the GPU and you've tuned your model with the batch size most appropriate for a particular GPU, yeah, you'll have to change some of those things in order to extract the maximum performance out of Gaudi. However, just to get it training on Gaudi is nothing but a change in targeting from GPU to the Habana Gaudi processor. That is our goal, that any model that trains on PyTorch or TensorFlow can train on Gaudi. Of course, there are always optimizations you can make in order to extract the maximum performance. Now, what we have done is taken nearly 40 models that are very, very popular within the industry, mostly focused on natural language processing, computer vision. And Habana has prepared an open source repository of all of those models. And there you can see how we've made certain small changes to the upstream model just to get it running on Gaudi. And then we've made a few other changes in order to optimize the performance of that model on Gaudi. So if you go to our GitHub repository, habana.ai, you'll be able to see the model references repository there, and that's where all of those models are stored. In addition, we have a website with full developer documentation and also forums where you can participate in a community of Gaudi users and share your best practices with each other and any kind of issues you run into. The community can help, and of course, Habana has engineers just like Jianying who are actively participating in those communities. All right, at this point, I'll hand it over to Jianying to talk a little bit more about the software architecture.
Hello, everyone. So here, the graph on the right is showing our basic software stack. So it covers from the driver that interacts with the hardware directly to the very up-level framework connection. So currently we support two frameworks. One is the PyTorch and the TensorFlow. So that will directly apply to your models. So we during the enabling, you only needed to change a few lines of the code to make it run through this whole Synapse AI software stack. Inside the stack, so we have first from the top to down. So first it is the framework integration layer, and below that is the key compilation part. So in that, the graph compiler that includes the Habana kernel library and also the communication library. Also, we provide like a customer kernel library. That means if the customer wanted to use some advanced feature to write their own library for better performance, they can. This is very similar to the SDK that NVIDIA provided. And also we provide some like a low-level debugging tools and also the profiling tools. You can find out what is the bottleneck of your run on Gaudi, so to do further optimization. So here I want to talk a little bit more about the PyTorch integration with the Synapse AI. So for the PyTorch Habana, so we provide some additional features in addition to the current what PyTorch public framework already offers. So we provide additional called the lazy mode. That is some kind of optimization from the current default eager mode. And also we provide the PyTorch Habana kernels that provide some fusion, so that can make your performance better for many kernels. That is embedded in the bridge. And also we provide some like all specific memory manager, some tools to like to check the output placement. And also we have our own distributed training integration with the Habana distributed libraries. And we have all mixed precision support, so that is mixed our FP32 and bflow 16. And we register on Habana ops and the kernels in the bridge as well. So the current support model categories for the PyTorch that is already have like the BERT, the NLP model, image classification models, resonant like computer vision models, SSD, and the segmentation models, and some language speech recognition models. So the code change is very simple. So for the key features for Habana support, you only need to do like one line or load Habana modules. And you can, because we support both eager mode and the lazy mode, the switch between these two, you also only need to change the flag. And for distributed training, we introduced the so-called HICO. So that is just the correspond to what like NVIDIA provided the NICO. So you only need to change the backend to be HICO. So then you can use the most of the rest of distributed data parallel as you always do, like in other backend. So this is the detailed resource, the link. You can find out more about the our integration, and also so as we are open to the like the public development in collaboration with the open source community. So we already have the integration with the PyTorch Lightning. So you can find out more the PyTorch Lightning integration in the or release docs. And also you can check out the model references in this link to our current supported models. And also you can check the developer site for some tutorials and videos. And also you can discuss your findings and ask your questions in this forum web page. So next, so we right now we have like active collaboration with Grid.ai. So right now we can hand this to a Grid, so they can do the demo on see how easy the PyTorch Lightning can run on Gaudi processors. Yeah, thank you, Koshish. Can get.
Yep, let's welcome Kaushik and let's see how you can use it with PyTorch Lightning. Thank you, Chin. Thank you, Miller. Hi, Kaushik. Kaushik, we cannot hear you. I think your mic is off.
Awesome. It was on mute. Sorry.
Yeah.
Yes. Hey everyone. Thank you for joining the stream. That was a great introduction to the Habana Accelerator and the software talk by our friends from Intel. So in my session, I will cover the internal architecture of our integration with Habana and how does it work with PyTorch Lightning. So we are very happy to announce like we added support for Habana Accelerator with the new release 1.6. So let's start with like what is an accelerator. So accelerator is refers to the hardware being used by PyTorch Lightning for training and inference applications. And we have added support for Habana Accelerator. But with that, we have also added support for like single device and distributed training strategies, right? And now I will cover the internal architecture of our accelerator and strategy API. So we are also happy to announce like with 1.6 release, we have declared the accelerator and strategy API as stable. As you can see in my screen, so this is the architecture of our strategy and accelerator API. So the strategy class takes care of the accelerator, precision, cluster environment, and checkpoint IO plugins. Every component is customizable and flexible. Here, as you can see, we have like currently 5 accelerators supported, including Habana, right? And this is how we started with the integration with Habana. Next, I'm going to cover how to start training with Habana. With the new Habana accelerator, you can train on single Habana device or like 8 Habana cores. So one Habana device comes with 8 cores. So we have two flags for the trainer class, accelerator and devices. You don't have to change your existing PyTorch Lightning code to leverage the Habana devices. You just have to switch the accelerator flag to HPU and change the number of devices being used for training. As you can see in the first code snippet, it's for like training on single Gaudi device. And second, if you want to like do distributed training, you just have to mention it to 8, which is the maximum on one Habana device. So in the sessions before, like Milind cover like how Habana devices are very cost efficient, and the some of the performances on some models it's like better than few GPUs as well. So we also have this feature for this devices flag called auto, which will auto recognize the Habana devices present on your system. So you might wonder how to access HPUs. It's very simple. It is provided by the AWS vendor where you can just go to the website and just get started with it. Second, the second part of HPU training is precision. So by default, HPU training happens with 32-bit precision, but we also provide a functionality to customize that. We do have this flag called plugins where you can pass the HPU precision plugin with multiple parameters, where you can provide the precision flag, the path to the operations for BF, BF16, and as well as for full precision 32. Where in this text files you mention the operations you want to provide a precision for. And you define the model, you define the data model, and then in the trainer you define the accelerator flag and the devices. Next, I'm going to cover the example where I will be running on the HPU machine, on the Habana machine. For that, I will show you the example. In this example, I will be like training it on the MNIST data set, and I've defined like a very simple image classifier. It is a Lightning module. It is subclass of the Lightning module, and it's written in PyTorch Lightning. So we define the model, we define the data model, and like in the trainer class, we define the maximum epochs is equal to 3, the accelerator flag as we defined before, the device's flag, and we're limiting the batches to 100 and for validation and training as well. Now we are going to run the example. As you can see in the logs here, these are the supported accelerators in the PyTorch Lightning hub. So you can see the HPUs is available and it's using one HPU over here. So the training has happened and the loss has converged and it's using the HPU's devices. That's it from my end. Like I covered the running the script part. You just have to, the main takeaway is like the usage, the usage of Habana is very useful efficiency and it gives amazing performance. And you can leverage the Habana devices by just switching the accelerator flag to HPU and devices flag to the number of devices to be used. Rohit, back to you.
Yeah, awesome. That was great. Looks like we can use Habana with just change by just changing the flags. I have a question. So, meanwhile, like users, if anyone have any questions, they can ask. But as you mentioned that it is possible to train on a single core use since Habana has like 8 cores available on a single device. So, is it possible to specify that core? Because the reason for asking this question is I was wondering if it is possible to use one Habana device for multiple jobs.
No, we will be using 8 Habana devices for distributed training.
Not for distributed, just for one single core training.
No, not yet.
Okay.
So it's in the roadmap to support multiple nodes, multiple Habana devices, but that's on the roadmap.
Oh, not no. I'm not asking about multiple nodes. I'm asking like let's say I have a device with me and it has 8 cores, and well, right now there is an option to launch it a script on a single core, right? By specifying devices equals to 1. Is it possible to launch it on a specific core? So because like on TPUs there's an option I can specify out of 8
Yes.
cores I can launch it on the 5th core. So is it possible with Habana right now?
So we haven't added that feature yet, but we can
Mhm.
plan to, yes.
Okay, awesome. So I guess this is all we had with Habana Accelerator. If from users, from viewers, if you guys have any questions, you can feel free to ask them. So in the meanwhile, we can wait for another 2 minutes and ask Milan like, what's the future scope of Habana? What's going to be the next thing with the accelerator? Any kind of support that we can look forward to?
Yeah, very good question. So we do. Habana has been acquired by Intel now, and as you can imagine, the integration into the larger Intel is an ongoing process. But Habana maintains its own product roadmap, so you can expect announcements in the near future about future versions of Gaudi that improve on performance and improve on other types of features for deep learning training. We also have an inference product. We had one early version of that product, Goya, that was released a few years ago. And we're now in coordination with Intel, kind of planning a future version of that product as well. So you will see additional training accelerators as well as inference accelerators from Habana, with a variety of innovative features to address deep learning and machine learning.
Awesome. So anyone else want to add anything before we end the stream? It looks like we don't have any questions yet.
So then the final takeaway would be like Like we would like the PyTorch Lightning users to check it out. We have a Slack. If they find any face any issues, they can like ask us. We are always happy to help.
Awesome.
Yeah, so I just want to give the like a short answer to the previous question. So you ask whether we can specify the which Gaudi to launch. So actually, in the like Habana Docker, so we have the Habana container, runtime container. So you can specify like using which Gaudi devices. So yes, I think we provide that feature. So I think it will be nice to like check the usability from like the user side. So we internally we do have that feature.
Okay, awesome. Looks like we just need to upstream it to Lightning and enable this feature.
Yeah.
Great.
Thank you.
So let's end this stream, and this was great, and have a good weekend, everyone.
Thank you.
Thank you.
Thanks for
Bye-bye.
joining.